started a little bit early, and so I'm gonna wait a little bit because when these events are set up, people don't get notifications until the time of, which is about 4 minutes, so. Oh boy. All right. I'm just gonna get started. This is the Go Component Lab, which is a sort of series that I'm doing Tuesdays and Thursdays, 5 p.m. Central. You can go to the events page and get reminded when these streams are happening, or look for upcoming ones. I'm really not putting in much more into the future than the current week. So here's Thursday, in which I'll be going back to a project that I was working on a couple Sundays ago, and somebody said they wanted to see me finish it. I was kind of on the fence about it, but since they said that, I'm going to come back to that on Thursday. What we're working on today is something I've been working on for the last 4 or so episodes. It's the sidecar supervisor. So if you missed out on any of that, the idea is sidecar supervisor made to run plugin daemons alongside your main process. So it's a library. It runs scripts and executables in a directory, then it watches the directory, and then if any of them change, they will restart. That's the basic idea. And all the log output for them is sort of treated in this way so that you can kind of direct it somewhere else. And in this example, this is using it, and so this mostly works. Here's an example of the library. So we create a new supervisor telling it we want to send everything to standard out. This could be any kind of IO. Tell the supervisor to watch. So that's just telling it to watch any of the things that it's loaded for changes. Then we load a directory, which looks like we take the first argument, and it's going to start all the executable things in that directory and then watch them. As they change, they'll restart. And it sits there and waits for them to all finish. So I guess we can try running this. Gonna run example. I forget if we need to pass the full directory. Should be using the current working directory, but I have this plugins directory here, so we'll try that. Okay, so what we're seeing is the output of the 2 things that it ran. Here's our plugins directory. We have 2 things in here. We actually have 3 things in here. We have date, which is a little bash script that loops and echoes the process ID and the date which includes the current time, and then it sleeps for a second. So you can see that. And it's has prefix date because it's called date. We have a Go file here called counter, which does something similar. It prints the process ID and the increments, and it sleeps for 2 seconds, just to create some variety here. So you can see an incrementing number here coming from counter. This is compiled to a binary, and so that's sort of done outside the loop of the supervisor. I actually have some kind of extension here, and I have it actually, if I edit counter.go, it will recompile it, which changes that file and then will cause the thing to reload. If I recall, the problem is it doesn't properly restart processes, so we're gonna see some strange behavior here if I change this. It didn't actually start the new thing, and didn't stop the old one. But it did notice the write. Actually, I think it did not. Yep. Okay, it didn't recompile properly. What's the problem here? This was working last time. I mean, this is executed in the root, right? It's weird. I would have thought that it would, can't load package. I mean, there's a main package in there. I don't know why it's, I suspect it is maybe confused about the working directory. I thought for sure these were all running in root of the project. This is an extension to VS Code, and man, I don't think I like it. I'm also still on the fence on VS Code in general, but package example plugins. Okay, oh, I didn't. Still using the old config. So clearly we have a working directory problem, and I'm not exactly sure we could do. Oh, it didn't want to do that. It's not actually doing a bash thing. That's kind of obnoxious, right? Oh, no, it's running in root. Why is it running in root? That's really stupid. There's gotta be some way I can tell it. See, I know nothing about this thing. Does transport place similar to? So does that work? Okay. Prototypes. It seems silly that it doesn't do that, but... And I'm not sure how I got into that state before and didn't do it. Let's see here. There we go. Remove create. So you can see it just keeps restarting it. So we've got a problem. Let's see, what should we do? Guess we'll stop it. And I guess kind of go through and see what happens when a change happens. So we had a remove event and then a create event. Which is interesting. It wasn't just a write. It didn't just write in place the binary. So we first stop this, which actually seemed to work if we were to comment this out and run this again. And change this back to 1. Oh, that's funny. Now it works. I think this makes sense because well, this isn't what we want it to do. If we tell it to stop, we want it to stop. Let's see how we're stopping it. Go and just call process kill. The problem is we wait for the exit status and we have a number of restarts that's going to do. So stopping, actually, you need a way to tell it let's see, it's so if we kill it, this will be it'll already have dereferenced this. This will, in theory, become, so we can actually check here. blocking issue here, though. If not okay, then return. So if we've removed it, we probably actually want to remove it before we kill it, so there's no kind of race. So it properly stopped. That's a start. I'm trying to think of how we could test for that, right? I don't know if stop is part of a public API, right? Yeah. Let's see. I don't know if we finished this. I'll do another supervisor. So let's see, what we can do is this will actually run something. Any of these, or we could make a new one. We could do standard out. Standard out's going to exit immediately. So maybe what we want is something that outputs something and then waits and then outputs something. Let's see how can, but we don't want to wait. Let's see, any ideas on how to test this? I mean, I guess we can just have a test process that blocks indefinitely. And if we call stop, it should kill it. And the test finishes. Otherwise, it would time out. So if stop fails, then we do something like that. So we can create a new fake program here called wait. And then we create a wait file, executable file in this memory map file system that we've passed to it. And then we load the directory so it'll run wait. Let's see. We have nothing to query what's running. I guess we have logs, but that doesn't represent a running process, so it'd actually be kind of nice to have something to get the status of a or the process ID might be the simplest thing, because that's the status. Like, either it's running and here's the process ID, you can do whatever you want with that process ID to query it. Otherwise it returns nil. So we can try that. So it would return we don't actually have the process ID directly. We have it under process. Where's process? Process. We could return a process. It could be helpful instead of just a PID. What would they call it? Just process? We want to get the process. Reload, stop, or process. We'll call it get for now. Let's see, no. I mean, that's probably good enough. Now, and otherwise we process That's the actual process. We don't even have to do any lookup. We can just return this. I'm gonna call it a process. Okay. So, back here, after we load the directory, we should be able to say, let's see, does that happen synchronously? Load directory. Yes. Well, reload happens. Reloadable happens, and then reload happens, and it does start the process. Okay. Okay. So we'll try and get that process. Get wait. There's an error here. I'll just say getting process. In other words, it didn't start. We can so then the idea is that we would well, thanks for asking, Lumi Late, and thanks for joining. Sidecar is popularized with Docker and Kubernetes, but there is kind of some ambiguity with that statement, because there's the idea of running in Kubernetes. You can run a pod, and a pod can run multiple containers, and so I guess what's become the colloquial way of talking about sidecars is you have your main Docker container and then you have your sidecar container running the same pod. However, within a Docker container, you can also have a sidecar process or co-process, where you have your main process and it's running something else. And so it's sort of like a different way to organize a program. In that case, it's running two processes in a single container versus running two processes across two containers. But in all cases, you have sort of like, it's all about one thing. It's a sidecar or like sidekick. I never liked the term sidecar. I always called them, I always liked the term co-process. Which is maybe more accurate here. I thought I would use the sidecar terminology because that was conceptually people would kind of get it. But the difference between this and something like a systemd or a init, obviously there's different kinds of supervisors. Most commonly, supervisors are your init process, like a systemd. There are supervisors that you can run that aren't intended to be run as your init process, like supervisor D, which is useful sometimes in certain cases where, for example, in development where you're running multiple processes, your web server and sort of like a Docker compose type of situation. This is different. This is different than all those common cases. The idea here is that I'm going to write a process. Actually, it doesn't matter if it's running Kubernetes or Docker, kind of irrelevant. The point is I'm going to make a process and it's going to run multiple child processes. So systemd, which is designed to run a system and run all the processes and services under init. This is basically just managing child processes of this process. For the particular use case of sub-processes that are sort of third-party, so plugins, how they communicate with the host processor, what they do is totally unrelated to what this does. All this does is give you a component that will run sidecar or co-process processes as daemons and give you an interface to minimally interact with them, but make sure that they run. And in that case, there's things that you want, like if they crash, you want to output the logs so that you can debug your plugin or whatever. But the other big thing is that it will watch the plugins, the directory that you tell it to load. And so as you change your plugins, it will actually reload them. So that's also a little different. So it's definitely a very specific and unique use case that you can't really summarize with a nice little title. But we'll see how this is used once we get it working, which we're pretty close. I was just working on a test for stop. Let me just see what we get here. I'm still like not sure what's going on with we don't want to run save go tests. Okay. Supervisor loader. Okay, panic worked. The test I based mine off of was not working. Why is that? This is not very helpful. It'd be nice to fix this up so this is more useful. An error, we can fix it. Running systemd in unprivileged containers is too complicated a solution. I mean, you know, there are 1,000 ways to do anything. If you want to run systemd in an unprivileged container for some reason to do something like this or really anything else, I really can't think of a good reason to do that, but you can. What I need to figure out is Maybe I can use that wrap. I haven't really used that error wrap thing. Yeah. This will help. Because we got a bunch of stuff. Errors, wrap. Oh, can't do that. Can we do that? This is intended as a replacement for errors, right? That's why it has new. So I guess I should explicitly tell it to use a different one. Not errors. This one. I need to add a colon, don't I? Because it's gonna... Oh, no, I don't. So you just have something to tell me what the hell was causing the error. Path in the directory. We don't really do that, so. Stat, open. See? Now we know it's this that fails. Do we have a wrap F? Cool. That's nice. Should probably all do that. Right, we're calling it with an empty open. So wait. Okay, that's weird. The open one is not one I put in here, did I? Is it? Stat is empty because our test is load directory, empty directory. memfs has a bug. It gets really buggy if you want to do root file stuff. If you're like this, it's like, I don't know what that is. It's like it shows the files, but then it can't read the directory. So you do this and it's supposed to work, but apparently it's causing more problems. But what's weird is there's two errors maybe. Unless this is somehow part of that other error. Do I need to have it make a directory? What if I put them in a direct? No, I don't want to do that. Actually, we did that. We could try running it at any path. So like this one would be bin. So we could say bin. And it works. See, it's just super buggy with the root stuff. I mean, that's, I wish, I mean, I still think it's probably one of the better file system abstractions out there, but it's still like, for Go, but it still has these quirks, or at least the memory map FS. I've run into other bugs too with it too. Let's see, so coming back to this one, we'll try to do that here and see what happens. Of course, it's just going to run forever. Although I would have thought that this would print out before then. But I guess if it's running these as like sub-processors or something, then we wouldn't see it till it's done. But I guess it times out in 30 seconds, so we'll see. It's really high timeout. Oh. Mm-hmm. Yep. Let me change that timeout, by the way. Let's see, where does that go? This is the user setting. I really don't want it to. God, didn't I do this again? I don't know about VS Code. I know, just do the right thing. Okay. So we did this output stuff. And then what we want to do is call stop. don't know what this error would be. There is no case where it would turn an error, but we'll just assume that there might be at some point. Okay. P declared not used. That's true. Yeah. Hmm. Supervisor 220. I forget, our maps, they're actually, are they immutable? So when you do a delete or something, it's actually replacing it? Oh, 320. It stopped it before it got to this. And so of course this is like, we could basically do this check before and after. Here we go. It'd be cool if this ran with the race test flags. Oh boy. What, we don't have race? Oh, there's... I didn't realize what I was supposed to be doing here. Hell races. And a race here and a race there. Yep. Well, let's take care of these. Supervisor 57. This is some older code. So we're reading in subprocesses standard error or standard out. Put it in a reader. And we call read. We need a buffer. I don't see what the problem here is, though. I did make a T. Let's see, so read lines. This is called with a T. Is this from to T reader? I'm gonna read and write into this, right? Maybe that's not the case. Because copy goes that way. I don't know why they would reverse that convention, but it's strange. Isn't that a convention? Like IO copy, you're always going in the direction of, I mean, you don't know what I'm putting at, but from right to left. But this is different. But, you know. So what I'm worried about is we've got a buffer. This is the circular buffer that it's talking about there. Okay, because these are running parallel, so that makes sense. We're writing to the same buffer. And it is not safe to write across coroutines on this circular buffer implementation. Well, we could wrap the circular buffer and create a new type where write is. Put a mutex on it. This makes sense, right? Because, yeah, there's another write. So, let's see. It'd be cool if there was like some kind of lock you could pass into something like T-Reader, and then it kind of uses it like a, I don't know, I'm thinking of like a gear, where it like, I mean that would kind of fix, that would do a lot of what I'm trying to do here anyway. I guess, unless anybody has a better idea. And create another type that embeds this buffer with a mutex. Actors. How do we use that here? And we could kind of implement a kind of actor-y thing with channels. But we're kind of limited to the types that we're working with here. T-Reader wants a writer. I wonder if there's anything in this in the standard library that just like that feels like something they could have, maybe in sync. No. We got a map, but I'm gonna do a quick look. Yeah, see, locked writer. I mean, easy enough. Easy enough. I'll just do this. There's a lot of this kind of stuff in Go where it's sort of like these patterns luckily are simple enough that it really doesn't warrant a library, and I really hate seeing libraries that package these things up like they think it's JavaScript or something. Like, if we do this, I was gonna embed the mutex, but might as well just embed the writer. Can you embed both? Is that possible? I guess let's put the method on it. See, this is all it took to create a locked writer. I don't know why I was... exported. It doesn't actually matter. That's a good point, though. If you were to make something that you wanted the public export interface to not have access to this mutex, which you probably wouldn't. You know, a lot of people would name it whatever. But in this case, it doesn't really matter. Even though this is exported itself, you know, at some point, if I were to kind of reorganize and rethink stuff, we might make this internal, because this isn't really a type that we need to export either. And that's more why it would be okay. You're right, though. If it was exported, it's like, yeah, you don't want a public lock there if you're not going to have a reason to use it. I think we can just do this. Oops. Oh boy. Does LW exist? Oh, line writer. Okay, silly. Can't do that. Whole buff. Timed out after 10 seconds. Did it lock and something else try to write and it can't? I don't know why. You know, it would write and it would unlock and then the other thing could write. I don't think there's a situation where they're dependent on each other. I mean, there's the read side of this too, which I'm not really thinking about, but I'm trying to understand why it would lock up. We got this going on. Gravity waiting on that lock. Wait group. Let's see, I don't think I understand why this would lock it up. Any ideas? What's that routine? And that's 106. Waiting for exited. Let's see. The thing we're writing into is a buffer that we don't really touch anywhere unless asked for. So I'm not sure why. Is there like a go? Yeah, can we do, does this work? It'd be cool to, actually I don't even know where I would do this. I mean, I almost don't need to do a debugging. I kind of just want to see what we're getting here. Wait, we're running standard out. Where's the standard out? There's nothing Oh. Oh. I think I just realized. Let's look at the implementation of this T reader. Oh, so we call read. And only if we get something will it call write. Yeah. Definitely worth trying. Make sure that that's what's going on here. Oh, that's interesting. Took 1 second. I guess it's starting a process. And we don't really know what this scheduler's doing. I don't know. That still seems long. But yeah, the timeout was not, is definitely related to this lock. I mean, I'm personally okay with this data race. Looks like they're all related to... Oh, not this one. Yeah, there's races in here that I care about, but I would love to solve this, right? I don't want to have to like create another Go routine to like... Kind of a crazy idea, but there's no real reason why it should matter whether these processes are run as in a pseudo terminal or not. If you did that, then you really don't have standard error, standard out. You just have standard out, and it doesn't matter. It's basically muxing them for us. Yeah, the delay is probably because I know it takes longer to run with the race mode. It's not public. I mean, it should be. Let me just. Good. Should be available at program prototypes. If you think you can play around with it. If you think you can figure it out, I will move on and ignore these races until another point, because we, you know, only have another hour here, so. And I'd like to make progress, so actually I'm just gonna do that either way, even if you don't think you can figure it out, but I'm sure you could. Thank you for looking into it. What do I think of GitHub being bought by Microsoft? What do you think, Dr. Bucket? Mock Watcher. Actually, we can open up to everybody. What are your thoughts on GitHub purchase, or Microsoft purchasing GitHub for $7.5 billion? I'm not worried about licensing stuff. I mean, there shouldn't be any difference. They're gonna probably retouch their terms of service, but if Microsoft were to build an internal or their own version of a GitHub, they would have to have terms that don't say they own your data. Oh, that's a good thing. I've never really looked. Nobody's ever really talked about it. There are terms of services are pretty tricky because you typically want to have enough license to do whatever you want with data so that you don't, so that you can do anything without any trouble. So that's why they very often the go-to thing for terms of services is such a like, we own your data because that's the safest thing. Alternatively, what's more common, I guess, because that's ridiculous, is you keep your data, but we'll have a very far-reaching and wide license to use your data however we want. That's usually more common. That's probably what GitHub has in their terms of service. And then from there you can get more specific, but usually anybody that has terms that say they own the stuff that you upload gets called out pretty quickly and they change it. So it's usually not like a malicious intent. It's usually just a lawyer who's like trying to do what they think is the safest thing. But yeah, embrace, expand, exterminate. It's a different Microsoft now. I mean, that strategy I haven't seen a whole lot of recently from anybody, really. So I don't know. What are your thoughts? Other people's thoughts? We got our tests running, so stop works. And if we go back to our example, which was causing our, based on the event, let's see, what was the event? On remove. So not only should our test pass, but the thing should work here. If we change counter, it will stop. Okay. I think we actually tested that already, but then we decided to write a test, and then it took a long time. But it's good. It's good for the code. Spend this time on it. But that, of course, is not exactly what we wanted to happen. We wanted not only for it to stop, but then for it to reload. So let's see what happens if we bring this back in. We'll just see what happens, because I know when we started today, it was just like restarting over and over and over. So we'll see. Seems to work as expected. I'll change it back to 1. Well, that's good. I wonder what our code coverage is so far. Just another slick. Thanks for following. I do have a follower goal for this quarter, so I appreciate all the follows. But you should also know that you can you can turn on notifications for me, but it's also a good idea if you're into this series is to click remind me on this event series, because I do a lot of other streaming game development. It's not Go, so if you're into Go, you should get reminded about this. Yeah, I'm curious what our coverage is. I actually don't really remember how to do coverage. Test cover. Easy. Should I? Thinking I add it here. %70 of statements. Coverage profile. Yeah, let's do that. Let's see what we get here. Whoa. Wait, so if we just do... we'll get there. I guess I'll add that. I'm gonna run it. Alright, is this readable? It's not really readable. Okay. So I'm guessing that's what this is about. Yep. 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 Those panics, we do not. I mean, those panics are panics for a reason. You should never get to them. We don't touch that. That's interesting. cases. I guess really I care about these, so yeah, testing logs would be a good idea. How is this? I mean, we use this. Wait, do we? No, I guess not. Okay, okay. There's definitely a lot of stuff that we should test, but it's sort of like that, you know, 90%. I feel like these are the things that we should try and test, and then we can kind of move on. We should test these as well. Maybe not so much the panics, but definitely situations where it needs to kill the process and stuff like that. And also retries, which honestly aren't that important to me, but that's pretty good, pretty good. So we can test logs pretty easily. Let's see, we want something that... Do we get both? The logs we get back is just like standard out and standard error combined, so... Standard error. I mean, we could do 2 tests. Standard out, standard error. Yeah. It's gonna run those. They're going to finish. Let's see. Wait. This is interesting. Does this work after a process is finished? I guess it depends. If the process finished, it doesn't explicitly remove anything here. Only if we stop it does it do that. And now we're storing logs. Factory. Wait, where are we in? Logs. P logs. Wait. What? No, wait, maybe that did make sense. Because we get it, and then... Okay. Process? So we did make a process type, that's right. So as long as we didn't stop it, there should be logs. So we can actually wait, I think. Wait for them to finish. Let me just remember if we're actually using this if we're using this correctly. We got a work group, and we can reload. Reload. Is it? Oh, yeah, it is. So we do that. So every time we reload, and it finishes. So it is waiting for all process to finish. Okay, that's all it is. Good. So. This is almost worthy of doing a table, but we're just checking two things. So I'm just going to do this again. This is getting me some bytes. Let's print it out. Okay, as you would expect, with a new line, right? Yeah, so. I mean, really? No, I guess we want to do gone. Okay, we can do that. This is a byte slice. I guess we can convert a string. Yes, let's do it. What do we get? This is our GOT. I wonder if that's gonna be weird, but oh well. And the same thing for standard error. Yep. All right. What was I thinking? What am I thinking? Can I do this? No. I'm not thinking the quickest way to convert a string to bytes. Or I could convert this to a string. Uh-oh. Yeah, I know that's what you want. Let's see what it looks like. Okay, I was curious about that. This past business and coverage. Wait, why would it do that though? The way we run these processes is without coverage, unless it's setting some environment to tell the subtest to have coverage. Can you explicitly turn coverage off? like cover equals 0, or I don't know what it's supposed to be. Yeah, it doesn't like that. Cover. Test cover? That's annoying that the way you run the tests will change whether or not they pass or not. So I do not want to give in to just not running this with cover, though I should try it. Yeah, it's still doing pass. How did the Go test do this? Because they didn't, I don't think they ran any other options here. I'm pretty sure I copied it exactly. What was that test for? Exec test. Go back. Yeah. It's not doing anything to say like disable coverage, disable pass output. Maybe it doesn't care about pass output though. Do you think maybe there's a way you can run without that obnoxious output? No. Oh, wait, what? Oh! I got you. No, I know what you mean. Hold on. No, I think you got it. I'm need to like convert test output. Do they clean it up maybe? No. Pass. Test run. Defer exit. These all explicitly exit. Maybe I need to do that. Yep. I think I can actually call writer.writer. I don't even need to name the thing. Let me, thank you for catching that and spending the time on that. It's amazing. Let me just make sure that this exits like that. I think that will make a difference. Did it? Shit, I think it did. Okay, I can almost do this, try your fix. exit, and then our test runs, and then right, I was gonna turn cover back on. We don't need this. All right, process logs. Process logs succeeded, passed. Even with coverage. Okay, cool. Okay, now I'll go back and turn race on. And we'll see our broken thing. Make this internal, like I mentioned. And here I should be able to do writer dot write. So I don't have to name it. I mean, what's one letter? So we're not using it yet, so we're getting the data race. Well, oddly, we are not getting the data race, but I will go there and where is it? Here, oh, start process. LBuff. Oops. Okay, so I don't know why I didn't detect it before, but I mean, race conditions aren't consistent, so in theory they're running the test a ton of times and stuff in parallel. I'm not sure exactly how they're testing it, but I think that's why you get a lot of extra time. So now these are the data races we care about. So I'm going to call that fixed with our circular buffer. Thank you. I guess I just realized your name is Crazy Root, or could be pronounced that way. I know I didn't before and you didn't say anything, but maybe you're like, why bother? Yeah. Crazy Root. It's easier to say. Alright, so these are the races we care about. Test supervisor load, probably having to do with maps, accessing our maps that we're not locking on. So load directory, reload. All right, so let's kind of go in and see what happens here. Most of the operations on the supervisor, it locks a mutex. Then if we have reload, which reloadable does its own lock unlock, and reload has lock unlock. So the locking doesn't happen until here. I mean, this is locked. If they're talking about, what are they talking about? Yeah, they're talking about this. I mean, we're locked, man. I'm not sure what the problem is. 355. Oh, 335. Oh, okay. I see. Sort of, but okay. I mean, we can get this. We can. I mean, all we care about. Yeah, this is the part where I thought there would be a problem. I mean, we could put a lock. Yeah, that's what I'm thinking. But, I mean, that makes sense for the actual working with the channel. But in this case, we want to check. I mean, in that case, we can just lock for those checks. Let's do this. Let's do this. See, I could skip this. See, the reason why we're checking is, yeah, we could just do a copy. We'd probably skip that lookup then. And this is the only lookup that we want to we care about. That, and then here we can use let's see, channel exited. I actually want to pass we'll try this. I don't think we have to pass it in. Look at that. We did it, Crazy Root. $75. It's close. What was the other thing that we didn't watch? I bet if we test watch, we'll. Crazy. How do you know I'm not just saying crazy? Okay, so the last thing to test is watch. Which we also are doing some debugging stuff here we can get rid of, but this sort of like way we set up our mock supervisor, which we probably should probably set this up. Okay, but then there's these events, watcher S, watcher, mock watcher. I should be able to access those. Well, it's a watcher, so I won't be able to. mock watcher. New mock supervisor is basically what I'm looking for. Looking at making here. New mock supervisor. I don't know. And then as we need to change stuff, we can make them arguments. Because we've got enough. I was gonna say, maybe we can start with this. Oh, we also need the buffer. Actually, we could create the buffer and return the buffer. I'm not gonna, I take it back. I'm not gonna do this abstraction here. I'm just gonna deal with these copies. Yeah, process logs. Okay, test supervisor watch. So we can use this watcher. This mock watcher and access these channels, and then we can test stuff. So let's see. If we were to change a file. Can we test this without, like, I'm trying to think we'd have to write programs that would simulate being different. Well, not necessarily, but some way to know that they've been stopped or reloaded. Maybe stop is the easiest one. If we were to send a remove event, then we can, you know, do the same test as we did for stop. For create, we can have it run something it wasn't running before. And check that that process is there now. Let's see, and write. Okay, I have a plan. I have a test plan. This is the plan. We're gonna run wait. And we're gonna run standard out. Yes, and that's it. So we load them up, and before we call wait, Okay, wait a second. Let's see. Okay, let's not create this one yet because it's supposed to not exist. And again, the events that would normally come out of these would happen when there's a real file system. So here I'm writing it, and then also I have to send these events. So we have a, what would we do? We do watcher, events, fs notify event. I actually don't know what this is. We could look at the source, I guess. Oh, name and op. Easy. And op is like, I actually do that here to test, right? We're testing that it is. That should be it. That should be it. Setting a create. Undefined S. What are we talking about? Oh, I was taking it from somewhere else. I knew I copied this. Took this code out from somewhere. This is actually going to time out because of this last test here. So first we write that file. And I think, God, if we're to write to a, yeah, we're not deleting it, so it will definitely, I don't know, what kind of byte? Zero. It's different output. And then we simulate that, standard out, hit right, I guess. Is that the other thing? Right, create and remove. Okay. And then we don't actually have to write these files, I don't think. So maybe I won't. We don't have to change these, I mean. They just need to be there so that it can pick them up in load dir. So we created it and we wrote it, and then we're going to say that weight has been removed, which should kill weight, which should make this pass through, whatever. Let's see. And this is all assuming that watch is being run. So we need to run watch. Right here. So, I guess in theory, this is the only one that it's actually testing. Otherwise, it would time out. So, I need to check to see that there is, let's see, I could, what would I do here? Do something like S logs. I'm assuming this event is fired after it's happened, so. Let's see, we can check that. Oof, oof. It's empty. Oh, I guess just because we sent the event doesn't mean it has been run yet. So, I mean, to test this, we can do a little sleep just to, you know. See that it works. Oh, it didn't work. It did create it. We got that. All right, see you crazy. I will hopefully see you next time. Thanks for helping out. Let's make this longer. Uh-oh. Data race. This time it's the read side. Alright, we can do a read write mutex, I guess. This would be, make this a read writer, and then this is a read write mutex. And I actually never used read write mutexes, so this is write. Okay, so I guess it's just lock and then rlock. I'm not gonna look it up, so we need to implement write or read. We're almost done here. IO read. Locked read writer now. Which makes that variable not as accurate. Least recently written. It's kind of confusing, yeah. So LRW. Oh, we have to update this now. Read writer. Read writer. Read. P. Okay. And then where we use that. this isn't a read writer. Maybe that is enough. Maybe that's all I need to do. Let's try it. Nope. Oh, buffer. Oh, we're not using read. We use string. Okay, at this point, why even get specific? We are going to just say LB. I was thinking LB. I was thinking of LD. Larry David. What is the thing that we use? Bytes? I think bytes. We wrap bytes. Supervisor logs bytes. Okay. Bytes is gonna give us some bytes. Bytes. Now what? Oh, do I actually not? Let me think about this. Maybe we didn't actually want a read-write lock. We just want a single lock. Yeah, that's probably it. Fine. That's luckily an implementation detail. Boom. Still? Wait, I don't understand. Is it something else? Maybe like logs. We log for the sidecar. And then buffer. Oh. We actually want to create it way up here. Yep. And then with start, I don't know where start is. Here, we would set it there. So we actually want to set this up there. And then say this is lbuff. I know, it probably locked. Because of the same thing. Look, I did it again. Crazy would be disappointed. Pass. Look at that. Our coverage is 82. My goal is 80%. So, for now, we can take out these, where are they? These debug thingies. We'll figure out the right way to do those later. I think though the next video though, we'll move on to a different component that uses this component. Or maybe I'll work on another component. We'll see. Until I decide on Thursday, I'm going to be working on that weird abstraction around exec and Docker and SSH. There's already a video of me exploring that. I think just one video. So I'll be working on that Thursday, and we'll come back around to this at some point next week. So, all right, that was fun and productive. Thank you, everybody that helped out, and yeah, I'll see you next. Next episode of Golang Component Lab. Trust me, it might be boring now, but once we get some steam and these components start coming together, some cool shit's gonna be happening. So, see you everybody.